Okay, we're talking over a type of problem that's one of the most complicated ones that you'd need to know for tomorrow. The test on exponentials. So if you were given a problem where you start with $500, after 9 years you end up with $1,500, and this monthly compounding piece is the tricky part, doing the monthly compounding. All right, I'd like you to see if you can set that up correctly. I'm going to pause for a second while you work on that. Okay, so our money tripled from 500 bucks to 1,500. What rate would have caused that? Let me show you how you set it up. Y equals AB to the X is the general format that you use. Then the start amount goes here. Start amount goes there, 500. End amount goes here. And that's 1,500. Raise your hand if you set that part up right. Okay, good. Then the B is a 1 plus a rate to the X. 1 plus the rate. I don't know what the rate is, but I got to figure that out. And then X is my time. And if I'm going to handle the monthly compounding thing, I have to do divide by 12 here, and I have to do 12 times the number of years there, because the years multiplied by 12 will make it into months. Now years was 9, so it's 9 times 12 goes up there. Do you get why it's not just the 9? Because it's monthly. So I'm changing this to monthly. So it's just like when we were doing those sequence deals, each little thing is going to be a month. Each little tick. So this is going to be 108. Okay. So that's 108, isn't it? Okay, good. So now I'm going to divide by 500 on both sides, and I get 3 equals 1 plus r over 12 to the 108. Now, how do I get the 108 off of there? What? To the power of 1 over 108. To the power of 1 over 108. When you take 3 to the power of 1 over 108, so it came out with, as if I did 3 to the power of parentheses 1 over 108, 1.0102. That equals 1 plus r over 12. Now I've got to subtract 1, and now I'll have 0.0102 equals r over 12. Now I got to times this puppy by 12. So subtract 1. And then times by 12. Final answer, 12.27%. Now where you rounded to, I didn't really say where you needed to round to. So as long as you knew it was about 12%, you were doing well. Raise your hand if you had that one right. Okay, good. So don't forget, if they do it monthly, you got to factor that in up in the exponent here too. Right there. All right, good enough on that. So we were grading that little practice quiz we did in class. Of the ones we graded, how many of you got a perfect paper? How many of you only had one wrong on the part we graded? Okay, good. If you got a bunch wrong, that's a sign for you. You need to study more than the other people. All right, next thing I'd like to do. I want to go through a few more real-world questions, kind of like what I just did there. I want you to see if you can set this up. You'll need your notes. Take some notes. It can be on your iPad. It's totally okay. Get to Notability, blank document. There's no notes posted. Or a piece of paper if you'd rather. I want to just do it on paper today. I'm fine with that. All right. Here we go. Set up a situation like this. A person has a car that is depreciated in value. I've been looking at buying a car that can pull my boat, and so I've been looking for Toyota Sequoias. That's the one I'm most interested in right now. And a Toyota Sequoia, back when it was originally purchased by somebody, was $44,000. Okay, I looked it up last night. I typed in the VIN number into the Toyota's website, and it told me what the purchase price of that vehicle would have been. The MSRP, manufacturer's suggested retail price. Okay, so $44,000 car. You're writing an equation, by the way, and it should look like that, kind of, except you're going to stick numbers in the right spots. All right, it currently is 14 years older, and it has been marked down to $6,000. I can buy the same car that costs $44,000 new for $6,000. Looks fine on the outside, but it's kind of used. I mean, it's almost used up, you might say. 14 years is old, but it's not dead yet. I mean, it still looks pretty nice inside. And so it all depends on how long that puppy will last. All right, so my question is, if I give you the start, the end, and I tell you it's 14 years old, you should be able to tell me the rate. It's not compounded monthly. Good question. Nope. Because that's not real world, to be honest. When you're doing monthly payments, it's real world. But when you're doing compounding for interest or compounding like this, you either do it by the year or you just, actually you do it with something called E that you don't even know about yet. So you should have said y equals a b to the x, but you know the a is the start value. Started at 44,000. You know the y is what it ended up being, 6,000. These are kind of backwards from the investment problems. Usually you start with money and then it makes you bigger. In this case, you're starting with buying this thing and it's not worth as much anymore. 14 years later, x is 14. And then the b, I would recommend you change that into a, what do you think? 1 plus r. Or 1 minus r would be just fine. All right. Then you divide by 44,000. And I'll see if you can take it from there. I'd like you to turn your answer my way so I can see it billboarded. All right, thank you. I'm just processing to see what the answers are that people are getting. Thank you, thank you, thank you, thank you. A lot of you guys are about the same. Thank you, thank you. Thank you. Is there a decimal in there? Okay. Yep, thank you. Thank you. Still waiting for a few of you. Thank you. Guy in the yellow shirt, got an answer? Oh, you did. Okay, thank you. Thank you. All right. Did you get one yet? Okay. All right. I'm going to put you out of your misery. It came out to 13 point, and then the only question was where the rounding should be. 13.26 is what a lot of you guys had. And then, of course, 13.3 would be pretty much the same thing, just rounded to a different spot. Okay, and that's a percent. So how is that done? First of all, you divide those two numbers on the calculator, and then you put them to the power of 1/14. That takes care of this part right there. And then my 1 plus r would be equal to the 1.1326. And then you subtract 1, and then that gets rid of this. And so there's your percent. What does that mean in the real world? This was an actual car that I can buy now. It's gone down 13% per year on average. Is that this kind of growth? Or is it this kind of growth? The blue or the red? It's not growth, sorry, decay. Decay. Is it, which kind of decay is it? Is it the black kind or the blue kind or the red kind? This is exponential. And exponentials are always curves, so it has to be the red kind. All right, and does it make sense? Do cars drop a lot at the beginning and then level off more at the end? Yes? It does, yeah. When you first buy a car, it drops down a lot because now it's a used car instead of a new car. They can get more money for new cars because they have warranties and other things that are nice about having a new car. Besides, if you buy the new car, you get to pick it all out. You can say, I want this color, and I want that option, and I want it to smell like roses or whatever. Okay. Now your next kind of exponential that I want to have you practice. X to the 3 halves minus 11 is equal to 16. Solve that. It's plain old-fashioned solve equation. Stay with me. There's a problem on the board. Try that one. Okay, I've registered 2 answers. Turn it my way when you think you have it. Thank you, thank you, thank you, thank you, thank you, thank you. I'm not saying right or wrong yet, just because I don't want people to assume. Okay, thank you, thank you, thank you, thank you, thank you. All right, excellent. You're all wrong. Or were you? All right, what did you think when I said that? What did you think you might have forgotten? Plus or minus. But think about it. Should, or extraneous is another possibility. That's what you should be thinking about on the test a lot. Now, on this problem, did you take a square root of both sides? No. Let me show you what I mean. Plus 11, plus 11. So this is x to the 3 halves equals 27. There is a square root in this problem, but what you did to both sides was a odd root. You did it to the 2/3 power. When you do it to an odd root, then the number on the bottom is the root. Remember, roots are on the bottom, just like in plants. If you do an odd root, it does not need the absolute value, and therefore there's just one answer, and it was 9. Raise your hand if you had it right. Okay, good. What's a problem where you would have 2 answers? Here's the simplest one I've been come back to. It's 4 and -4, right? Why? Because when you take the square root of both sides, it's like you're doing this to the 1/2 power. It's a little cleaner than the square root symbol to put it to a 1/2 exponent like that. And when you do that, you're taking a square root that brings in absolute value of x. It does not mean that square root of 16 is 2 things. Square root of 16 is just 4. It's because there's an absolute value on this that causes x equals 4 and x equals -4. This is a really common wrong answer I get nowadays. What is 144 to the 1/2 power? What do you think the wrong answer is that I get? Well, first of all, what's the right answer? What? Say it louder. 12. That is the right answer. What do you think the wrong answer is that I get? Plus and minus 12. And it's not right, because if I had an equation like this and I did that to both sides, this would be absolute value of x equals 12, and that would cause 2 answers. But the square root of 144 is just 12, not plus and minus 12. If I had this equation to solve, then the answer would come out to plus and minus 12. Okay, good enough. Now, let me give you one more real-world situation. The moose in Minnesota, the moose population is dropping, and they're not sure why. They think it's this tick that has been bothering the moose. You see these moose that have gotten just covered with these ticks, and they can't get them off of themselves. You imagine, like, we have fingers we can pick with, you know, like grab and pull something off of ourselves. Imagine if you didn't have that. Like, you don't have fingers. All you could do is, like, rub and try to get the stupid thing off of you. Okay, or it was on your shoulder, you can't bite it off because, you know, we can't get to it. So anyway, it'd be nasty, wouldn't it? Well, these moose are declining in population. Let's start with this scenario. There's 12,000 moose in Minnesota, and the rate is dropping by 0.4%. I'm doing this on purpose. The rate is dropping by 0.4%. So right off the bat, you write y equals, what was the starting value? 12,000. Dropping by 0.4%. Here's one common answer I get where they go 0.4. Oh, it's wrong in so many ways. Okay? 0.4% drop means I start with 1, and I'm dropping by 0.4. Here's the second most common wrong answer. It's not quite as wrong as the other one, but why is that wrong? That'd be 40%. 0.4% is like this. 0.04, is that right? No, that's 4%. 0.4%, 0.004. How many of you had that right before I said it? Okay, good. All right. And what other thing do I need to make this exponential? An x in the exponent. That's what makes something exponential. All right. There's a lot more concepts than that, but I was going over some of the ones that trick people sometimes. What should we profile and watch out for? Square roots. So if there's a square root in the problem like this, then you got to watch out because your answer might come out and it might have all worked out perfectly and you get the answer of 3, and then when you actually do it, it doesn't work. So check your answers on problems like this because sometimes they don't work. If I did solve this one and squared both sides, I'd have x plus 3 equals x. Is that even possible? So what do? Minus x and minus x. If you ever have this situation, get rid of the variable. And if it comes out to 3 equals 0, that means there is no solution. There is no answer in the world that could ever make that right. It is impossible. No solutions. Okay, so if you have something like this, x plus 3 equals x minus 5, get rid of the variable. And it'll say something, a statement, and if the statement's true, it'll be everything works. If the statement's false, like this, no solutions. Okay, show you one that's true. X plus 3 is equal to 1 plus x plus 2. Do you get how that's actually really x plus 3 over there? Okay, if I subtract x from both sides, not knowing that, I draw the thing like this, I get 3 equals 1 plus 2. If you get a true statement when you subtract the variable, you have not figured out the answer. You figured out that there are infinite answers. Instead of no solutions, you figured out that all real numbers work. So like if I put in 6, is this thing true? 6 plus 3 is equal to 1 plus 6 plus 2. Yeah, it works. And you find that everything works. So some equations are no solutions. Some equations are everything works, or all real numbers. Instead of no real numbers, all real numbers. Yes? Think about this. If you were to graph this, y equals and y equals. If I graph both sides and see where they cross, I get my answer. Well, what happens is when you graph this, they are identical, right? They have a slope of 1 and they have a y-intercept of 3, and so they both are right exactly here. And then if I say where do they touch, well, they always touch. So therefore the answer is everything works. Any x would work. Pick any x, they'll be right on top of each other and they'll be the same thing. Okay, enough about that. Your homework for today. I want you to finish up the worksheet that was posted yesterday, and you did the first page of it yesterday. You're just finishing that same worksheet. That makes it a relatively easy homework assignment. And then in class for the next 20 minutes or so, I want you to take one more like 6-question exponentials quiz. We did already did exponentials 1 and exponentials 2 on the Schoology deal. Do the exponentials quiz number 3 on Schoology, and I want you to start that right now. That's all I have for the video for today.